we are discussing about stick fixed neutral point. We are still talking about wing plus tail airplane configuration. Okay. So, we have written down the expression for the CMCG using this picture. All right, expression for CMCG after some simplifications. Is this right? Now, this CLW has two components, right? One is changing with alpha and other one is a constant. So, you can write down Cm naught for the wing plus tail airplane configuration is and Cm alpha for wing plus tail configuration is alright. So, this is dCm over d alpha, right. What is the definition of the neutral point? When this quantity becomes 0. So, I can replace this quantity by x and p, right. So, neutral point is the location of the Cg where dCm over d alpha becomes 0, right. Right. So, you can set this to 0 and find out what is x and p. Let us call this 1 and the other one is 2. And let us subtract 1 from 2. Okay. So, let us first also rewrite this equation 1 in some other form, which is dCm over dCl. Okay. So, many books you will see they are finding an equivalent expression for this, okay, which is dCm over dCl. Right. CL alpha is going to be positive for any airfoil you choose, negatively cambered, positively cambered or symmetric. So, this is not going to have any effect on the stability because it is a positive quantity, right. When you do this, you normally take this CL as the CL of the wing, right, because that is dominant, right. The CL produced by the wing is much more than the lift produced by the tail. So, this is of the wing, right. So, I can use this one and find out what DCM over DCL is, and that is right. We can also rewrite this. Is it correct? Now, subtract three from 2 prime. Okay. What do we get? This part is same in both the equations, right. So, what we get is right. This quantity is, so DCM over TCL negative is X and P over C bar minus XCG over C bar, right. And this quantity is known as the static margin. From pilot's experience of flying conventional airplanes, it has been found that for good handling qualities of aircraft, this HN should be 5% of, it should be 5%. Okay. So, XNP minus XCG should be 5% of the mean aerodynamic chord. We will talk about this a little later. Okay. All right. So, clearly this Hn has to be positive, right. That means xCg has to lie ahead of xNP. Zero is at the wing leading edge. Okay. So, this is what is called static margin or SM. So, let us try to look at what is happening graphically. Draw CM versus CL plot. So, DCM over DCL is negative for this curve, right, and that means CG is lying ahead of the neutral point. Right. You move CG backward and then there is a point where xCg is lying right on the x and p, and then you have neutral stability, right. So, this is for stable case, this line is for neutrally stable airplane. So, clearly if we want to maintain stability, ensure stability for all CG location, the CG should not go beyond the neutral point, right, that is what it means. So, I can say that neutral point location is the most aft location of the center of gravity, right, if you want to ensure stability. Okay, let me write that statement somewhere or maybe there itself. Remember, we have now found the aftmost location of CG, right. You have to ensure that whatever is happening on your aircraft, the CG should not go behind the neutral point, right. So, people can be properly seated and not all of them should move simultaneously backward, so that CG has shifted beyond this neutral point location, right. So, that is the reason why crew will ask you not to move around much, right.
Initial CG
after we have sort of properly placed the loads, right, and now the aircraft is going to take off. There are two situations. One is fuel will be consumed, right, and that will have an effect on the CG. The other situation is when people can move on the aircraft, right, but that they will take care of. Okay. So, I would assume that is the CG when we take off, okay. And even before takeoff you will have some run on the runway, right. So, only major consideration would be how you are going to place your loads on the aircraft, right, and after that is the fuel. Anyhow, this margin is going to take care of some other aspects, like how loads are getting redistributed over the airplane. So, now I can draw some arrows. So, on this line instability means going away from something, and stability means converging, right. So, at this point clearly we do not know, when you are neutrally stable I cannot draw any direction to whether is something will converge to it or diverge, right, coming and going this arrow through this neutral point line. Is this all right? Okay, now let us discuss about the most forward location of the CG, right. This we talked about the most aft location of the CG, right. What is the most forward location of the CG? Yeah,
aerodynamic center
aerodynamic center.
of the wing.
That is in the case when
it's flying.
If it is a flying wing,
yeah,
it is a flying wing.
that is only when the lift produced on the tail is acting in the upward direction, isn't it? I can always have the lift produced on the tail in the negative direction, right. So, the effect on stability from the tail is destabilizing, right. If I have lift on the tail acting in the downward direction, then what happens? Is going to give a
additional moment to that.
yeah positive moment, right. So, both of them will become actually destabilizing. When the lift produced on the tail is negative, then the contribution from the wing, which is already destabilizing, right, and tail will also start having a destabilizing effect on the pitch stability, isn't it? If I say lift is this, right, the moment about CG is going to be in this direction. Now, where should the CG lie? I can have such a situation, right? Right. So, you can clearly see that aerodynamic center of the wing is not the most forward location of the CG, right. How would you define that? What all you have to ensure? Remember, we talked about maintaining trim, and for trim CM CG must be 0, right. What is the other condition? No, let us talk about the trim first. So, we will talk about level flight condition. That is what this is. Remember, we talked about this. So, aircraft is going in the forward direction, so relative velocity is v along the x axis. This is for the case when alpha is 0, angle of attack is 0, and then to find a trim you not only have to balance out the forces, but also the moment, right. The expression for the moment I have written here, CM CG should be 0, right. Or you can write it like this, right. So, this we get from here. So, what is the other condition? Thrust should be equal to the drag, let us say we have ensured that, and lift should be equal to the weight, and this lift is the sum of the lift produced by the wing and the tail, right. This may be small as compared to this, but still we have to account for that when we are talking about producing negative lift, right. If I am producing negative lift, that means W is LW, right. So, when you are producing negative lift at the tail, still you have to ensure that this condition is satisfied, isn't it? This has to be satisfied to maintain the equilibrium. Let us say we can somehow manage to satisfy this. Okay, we have enough lift produced from the wing which can take care of this small negative lift produced by the tail, right. And how do you produce negative lift by the tail? This is going to depend on the camber, right. To start with, we said that the tail is always going to be having symmetric airfoil, right. What is going to change the camber of the tail? Elevator. So, this LT negative LT max is going to depend upon how much maximum elevator deflection you can have in the upward direction, right. Is it all right? So, you have to think about that situation, right, corresponding to delta E maximum upward deflection, elevator maximum upward deflection, this LT max negative, right, can be compensated by the lift produced on the wing, so that this quantity is able to maintain the weight, right. Okay. So, with this, now go back to this equation. The question is, if the tail lift is acting in the downward or negative direction, where should the CG lie? Ahead of the aerodynamic center of the. Okay. So, in this case, in the case when the lift is acting in the negative direction, CG can lie ahead of the aerodynamic center of the wing. Okay. Now, question is whether you want that or not. So, CMCG now can be maintained 0, because this destabilizing effect can be compensated by the stabilizing effect of the wing, right. When CG is lying ahead of the AC, then you are going to get a stabilizing effect coming from the wing. would you want to go into such a situation? Would you want, I mean now clearly we have, no, we can maintain the equilibrium, we can also maintain stability, right. What will be Cm naught? Cm naught is still going to be positive, right. So, I am satisfying all the criteria, I am satisfying Cm naught greater than 0 and you have Cm alpha less than 0, right, and trim is maintained. Would you want such an airplane where you can have your CG moving ahead of the aerodynamic center? But clearly we can have it, right. So, mathematically we can prove that CG can go beyond this aerodynamic center of the wing, right, ahead of this point, if the lift can be maintained negative at the tail. Question is, would you want such an airplane? Why?
A sudden increase in lift will keep on increasing the angle of.
I mean, sir, we have to.
There is a. Suppose there is an increase in lift, then alpha will change.
Yes.
That is what is stable and stable, right?
The lift at the tail is negative, the main wing has to work more to lift the same.
Right. So,
Your
performance of the aircraft will go down, isn't it? Because lift, negative lift means this wing will take, no, this lift has to be, no, has to compensate for. So, wing has to work more, as you said, right. And what is the problem that is going to come to the wing because of that? High wing loading, right. And that is going to have a bad effect on the health of the wing, right. By the way, people do worry about the structural health of now mechanical systems. Okay, there is a whole lot of research on this topic. Performance of aircraft will also suffer, right, because if this lift has to go high, your angle of attack has to be high, and that is going to cause or create more drag, right. More lift is also giving you more drag. So, definitely is going to have an effect. Okay, but now you know, I mean, where you can have the most forward location of the CG, right. I would not say it should be at the aerodynamic center of the wing, because if it is going to that side, then we have to again satisfy all the criteria and also look for the best performance of the aircraft. So, performance and stability are actually connected, right. All right, but there are different kind of airplanes, right. We do have airplanes with canard in front, right, the tail in front of the wing, isn't it. So, again we have to repeat this stuff, we have to see if we can maintain the trim, you can see if we are satisfying the stability criteria, we have to see if we can fly at positive angle of attack, right. So, all of these are have to be worked out for any airplane you talk about, isn't it. Any question? But we haven't added the other effects, there are other parts also which are going to contribute to the location of the neutral point. So, we will look at the effect coming from the power plant and also from the fuselage, right. Fuselage actually has a coupled effect, it is going to influence the wing is also going to influence the fuselage. So, that is interference effect. Anything else? Which is other body which is looking like a fuselage mounted on an airplane? Yeah? Yep, that is for combat aircraft, right. But for normal transport aircraft, so power plant is also the encased within what is called engine nacelle, right,
Yes.
and that is also looking like fuselage, body of revolution.
Yes, sir.
Right, and it is going to contribute to Cm alpha, right. And fuselage wing so all these three effects we are going to add to our equations, right. Anything else? Effect of the rotating propellers, yeah, jet engines, right. So, we are going to talk about all that in the next class. So, they will all come together under one subtitle which will be power effects, okay. So, in the next class we will talk about the effects coming from these three components, and then we will look at the power effects, right. So, we can stop for today.